Welcome back to Honors Biology. Today we'll be talking about lipids, one of our key four macromolecules. So lipids typically refer to the fats and oils that we find in most living things. They're going to be a form of lipids. Lipids compose of a couple of different structures, and we'll go through that. The first basic lipid structure is lipids are just long chains of carbon, hydrogen, and oxygens. So the same elements that make up carbohydrates, carbon, hydrogen, oxygen, also compose lipids. Lipids come in, but the difference though between carbs and lipids, even though they share their same elements, lipids are insoluble in water, meaning that they do not dissolve in water. Oils, like olive oil or vegetable oil, is an example of a lipid. If you mix oil and water, they don't mix together. So where you can dissolve sugar in water, you cannot dissolve oil in water. So that's one of the big differences between lipids and carbs. Lipids, this is what typical lipids look like, all right? We have two different kinds, saturated versus unsaturated fatty acids. So this is what a fatty acid looks like. Long chains of carbon just attached to hydrogen. Saturated fatty acids look just like this, super long chains, and it's saturated, meaning it's filled with hydrogen. So there's as much hydrogen as we can in a saturated fatty acid. An unsaturated fatty acid is not filled with hydrogens. There's a kink in the carbon. There's a double bond here, which causes a kink to form, and it's not filled with hydrogens. If we look up here, there's two hydrogens here. We're down here, there's no hydrogens. So saturated fatty acids are filled to the brim of as many hydrogens as possible. Unsaturated fatty acids, there's double bonds in there causing them to not be as filled with hydrogens. When we get into talking about unsaturated versus saturated versus trans fats, as you may hear, couple key differences. Unsaturated fats, as you know, right, have a double bond in there, they form a kink. Two big things with unsaturated fatty acids. One, they're mostly found in plants. So avocados have unsaturated fatty acids, olive oil, sunflowers, tomatoes. Most of the oil from plants is unsaturated. It's also, most of the fats from plants are liquid at room temperature. So unsaturated fatty acids are liquid at room temperature and they come from plants. Saturated fatty acids, these are the ones that come from animals. So the fat in chicken or beef, pork, whatever it is, in bacon, in milk and ice cream, that is all for the most part solid at room temperature and comes from animals. So unsaturated, liquid at room temperature comes from plants. Saturated comes from animals, solid at room temperature. When we talk about in terms of a diet, a lot of dietitians recommend eating unsaturated fatty acids. These you can eat however much of and you're fine. These are the good fats. Saturated fatty acids, they recommend staying away from. You can still, we can still eat bacon and that's fine. Stuff is good in moderation, but they recommend limiting your intake on these. Trans fats, on the other hand, this is the stuff that's typically deep fried. French fries, chicken nuggets, frozen food has a lot of trans fats in it. This is what they recommend you not eating. All of this stuff, even though it tastes great, isn't good for you. These are a lot of the bad fatty acids that exist in our body. So There's a couple differences between the three. One of the thing your body does, so fats are used for energy. Whatever fat is not used right away and for energy gets converted into long-term energy storage. Lipids, fats are used as a long-term energy solution. So where carbohydrates are good for a quick burst of energy, it's the sugar, we'll burn it off quickly. We burn slowly lipids. Fats we burn slowly over time. Your body will convert fatty acids into what's called a triglyceride. A triglyceride, if you break down the name, tri means three, and glyceride. The name implies we have a glycerol, which is this part here, and tri means three. So we have a glycerol here, and then we have three fatty acid chains. Triglyceride. Glycerol with three fatty acids in it. This is what a lot of the fat in your body looks like. It's in a triglyceride form. So be aware that this is what your body will store fat as, a triglyceride. So this glycerol and this free fatty acid, while it forms triglyceride in the body, it can also form what we refer to as a phospholipid. Phospholipids have two parts to them. They have a hydrophilic head, which part of it is glycerol, and a hydrophobic tail, which is fatty acid. So the phospholipids have a polar head and a non-polar tail. So phospholipids have a water-loving head and a water-fearing tail. When a bunch of these get together, they'll form what is referred to as a phospholipid bilayer, with the water-loving heads pointing out, because that's where most of the water is in our body, and the hydrophobic, the water-fearing tails pointing in. Our cell membranes are phospholipid bilayers, and we'll talk more about this when we talk about the cell membrane and transport. Up to this point, we've been talking about lipids as being fats and acids and oils, but that's not all lipids are. Lipids can also be classified as steroids. Steroids are a very unique structure. Steroids are a four-ring structure. All right, that's the key part to steroids there, is it has four rings. So cholesterol is a steroid. 1, 2, 3, 4. Estrogen is a steroid. 1, 2, 3, 4. Your hormones are also considered steroids as well. They have a four-ring structure to them, and they're considered to be lipids. So steroids do a lot of different things for our body depending on what the steroid is, right? Cholesterol helps with regulation of blood flow. We know too much cholesterol is bad for you. Estrogen is the main female hormone, whereas testosterone is the main male hormone. So dopamine is a hormone steroid that gets created, and they all have the same relative structure of the four rings. So make sure you're able to identify, hey, I see four rings, that's a steroid. If you have any questions, make sure you write them down. That's it for lipids. I'll see you all next time in class. Have a great day. Bye.